In this section, I will calculate a limits of the function using a limits property. Okay, limit number 1. Limit as x approaches 5 of the rational function x squared plus 4x minus 45 all over x minus 5. That means having this type of limit, we can always try to start with the direct substitution. That means let's see what's happened if I substitute 5. 5 squared plus 4 times 5 minus 45 all over 5 minus 5. Denominator is 0, definitely. And then 25 plus 20, it's 45, minus 45 is 0. Okay, that means I get the form that is called indeterminate form, or simply at the moment undefined, and I can't assume anything. Please remember, 0 over 0 is not telling me right away that the answer is 0. This answer could be 0 or could be also a finite number. One message that I'm getting from this expression, I'm getting the information that the polynomial on the top and polynomial in the denominator has a common factor. They have common factor as x is 5. That means I will try to rewrite this expression, rewrite this function, find the common factor, cancel out, and then I can see what's happened. Okay, let's try to factor out numerator. I do have x minus 5. I have x and x. 45 is giving me the is the product of 5 times 9, and then plus 9 minus 5 is giving me 4x. Okay, excellent. I definitely see my common factor. I can cancel out, and now I end up having x plus 9 over 1, which actually I don't have to write over 1, denominator 1. Okay, that's me. Now I did simplify my expression, and I did eliminate 0 from the denominator. That's the most important, and I think I can use the direct substitution. I can substitute 5 instead of x. The limit is 14. That means the behavior of this function at 5, it's 14. I don't know exactly how function looks like, okay, but just the idea, at 5, function is approaching 14. My scale is a little bit off, but we can see it's definitely a discontinuity because function is not defined at 5. Because 5 is giving me 0 in the denominator. Okay? That means this is of course not the right function, but the behavior at 5 is presented correctly. Okay? That means that's the way to solve the limit. And please notice 0 over 0 didn't give me the answer 0. Okay, limit number 2. Let's take a limit as x goes to negative 3, x squared minus 9, and then in the denominator x squared plus 2x minus 3. Okay. That means what I see again a rational function, the ratio of two polynomials, and we have to investigate the behavior at negative 3. Okay, let's do the same. Let's try directly substituting negative 3, and let's see what's happened. Negative 3 squared is 9, 9 minus 9. Okay, I see, it's 0. And then negative 3 squared again is 9. Negative 3 times 2 is negative 6 minus 3. Okay, again, similar situation. 0 over 0. Okay. Please remember, we might get the 0, but you really have to have a strong reason. Prove it. Okay, that's me. Let's do the same. 0 over 0 is undefined form. we have to find a common factor, because that's the message from this expression. These two polynomials has a common factor at -3. I can factor out nicely x squared minus 9 as a x minus 3x plus 3, and the polynomial in the denominator I can put 1 and 3 as a factors of -3, and then I need +3 minus 1 will give me +2. Really nice. I see my common factor, x plus 3, x plus 3, and now x plus 3 was my 0. That's mean you can see I did cancel out that 0. That's mean now I did simplify, and I have x minus 3 over x minus 1. I think I can directly substitute -3 minus 3, -3 minus 1, -6 over -4. The answer is +3 over 2. This means again we have a situation that function doesn't have a value at -3, but the limit exists. I can try to show you this situation. Okay, at -3 the limit is 3/2, and I don't know exactly how the function looks like, but let's say this, because I'm only looking at the neighborhood of -3. Okay, the limit is 3/2, but please note function is not defined at 3. Okay, limit number 3. Let's actually take the same function, x squared minus 9 over x squared plus 2x minus 3, and let's investigate the behavior at 1. That means what's happened? Direct substitution will tell me 1 minus 9, 1 plus 2 minus 3, -8 over 0. Okay, that means again it's undefined form, but now this output, this solution, this quantity -8 over 0 is not telling me that this function, I mean these polynomials from the top and from the bottom has the same has the common factor. No. That means probably this case, I mean definitely is undefined, but negative, like a finite number over small number, will result in the huge number, positive or negative. That's mean, please remember that's the only two options that you have to investigate, but that's the only two options. A finite number like -8 over 0, it's definitely not 0, okay? And definitely not a finite number, because right away I have the information that is no common factor. I can't find a common factor that will be cancelled out. They might have common factor, but not at 1, because we actually know from the previous one that it exists a common factor, x plus 3, but not at 1. That means let's see, the answer must be big number, arithmetically of course, dividing a finite number over small number. That small number 0 will give me positive or negative big number. That means let's investigate. Okay. A limit as x goes to 1, and let's simplify. That means I will copy the same things. I will factor out this, and I will factor out -3, it's 3 and 1, positive and negative. And we know that I can cancel out. That means you can see we actually have a common factor, but not at 1. Finding this common factor, the other one, I didn't simplify my 0 from the denominator. That means now the direct substitution is -2 over 0. And I have to check if this 0, of course, is not really 0, it's just a small number. Okay? But we have to find out if it's positive or negative. That means, just to simplify a little bit, I will add the right-hand side. Okay? That means I will just check the behavior from the right-hand side. Left-hand side will be respectively the same process applied. That means now, if I know that this is not really 0 because this is not really 1. It's 1.1 or maybe 1.01 or maybe 1.001. Tiny number, I mean close number, really, really close number to 1. And when I subtract 1, I have small number, but actually positive. We can see tiny number, but positive. Tiny number, but positive. That means this is the 0, that is, the value 0 from the right-hand side. That means now we have to use the arithmetic, of course. Negative 2 and positive, it's negative, and 2 over small number is a big number. That means negative infinity is the final answer. And again, I can try to show what is happening with this function based on that results. If I'm getting infinity, we know that this will be a vertical asymptote at 1, and from the right hand side function will go down, negative infinity. And we did have the behavior at 3, as we remember, it was 3/2. Am I right? Yes. Okay, that's me just to show you, but the limit is negative infinity. Okay, let's take another limit number 4. Limit as x goes to maybe one more polynomial, 3, and then x minus 1 squared minus 4, x minus 3. Okay, direct substitution, 3 minus 1 is 2, 2 squared is 4, 4 minus 4, 3 minus 3, again 0 over 0. The answer is most likely not 0. I know that is common factor. Let's find out the common factor, cancel out, and use the direct substitution. Limit as x goes to 3. First of all, I will expand this. X minus 1 squared is x squared minus 2x plus 1 minus 4. Okay. Limit as x goes to 3. X squared plus 2x minus 3, because plus 1 and minus 4 is negative 3, x minus 3. I think I have to factor out the quadratic expression, and x minus 3 is in the simplest form. Again, 3 and 1. Am I right? Because something is, oh, I know, I did the mistake. I see. This is supposed to be minus because I didn't copy. That means this is minus and plus because I was looking at the common factor. That means x minus 3, that's my 0. The 0 is gone. Now I can use the direct substitution. Just x plus 1. 3 plus 1, of course, is 4. The limit is 4. And if we would like to check just the situation at 4, please remember, not at 4, limit is 4. Limit at 3, the limit is 4. Whatever is the behavior of the function. But we can see no value, empty, removable discontinuity. Okay. Another calculation, limit number 5. Limit as x goes to 36, square root of x minus 6, and x minus 36. The direct substitution, root of 36 is 6, 6 minus 6, 0, and of course 36 minus 36. Again, 0 over 0 is telling me that we do have a common factor. Let's factor out, cancel out, and use the direct substitution. Hopefully we will get a finite number different than 0. In order to simplify this or to find the common factor, we normally applying, if we see the root function, we multiplying and dividing by the conjugate expression. Conjugate expression is the expression with the square root, but instead of subtracting 6, we adding 6. Square root of x plus 6, square root of x plus 6. Okay, and let's multiply. Limit as x goes to 36. And now I will actually keep the product form in the denominator, because we remember x minus 36, this is my 0, 36 minus 36. I really have to keep this. If I will distribute, I will really lose that 0. I will spread out and I'm not gonna find it out. I'm not gonna recover back. But the conjugate expression, of course, I will FOIL. That means I'm using a minus b, a plus b. This expression is equal to square the first quantity, square the second quantity, and the minus between. Okay, square root of x squared is x, and 6 squared is 36. And now I see my common factor, x minus 36, x minus 36. Excellent. The job is done. Limit as x goes to 36, and now I can definitely use the direct substitution. Square root of 36 plus 6. 6 plus 6 is 12. 1 over 12 is the finite answer. That means again the limit was at 36. That means this is 36, and limit is 112. It's not a value, please remember, it's simply a value of the limit. Okay? And this is function. Of course, I don't know exactly how the function looks like, but that's the idea, close to 36. Okay, now let's try a little bit more complex. Limit number 6. Limit as x goes to negative 4, x squared plus 4x, in the denominator x squared minus 7, square root minus 3. That means let's check what we have. Direct substitution. Negative 4 squared is 16. 4 times negative 4 is negative 16. Negative 4 squared is 16, minus 7 is 9, and this is 0, and this is also 0. Again, 0 over 0, we're looking for the common factor at negative 4, because this indicates that we do have a common factor at negative 4. I mean functions from the denominator and numerator. And again, I see the root expression. I will multiply and divide by the conjugate. I can possibly factor out x squared minus 7 minus 3, and the conjugate expression is the same square root but plus 3. The same square root but plus 3. This stays the same. We have to copy the same first term. And the conjugate expressions I will distribute, but not the other one. Limit as x goes to negative 4, and let's see what we have. I will copy x plus 4, and then square root plus 3, x squared minus 7, and now multiplying the conjugate expressions is the same thing. Square the first quantity, square the square root of x squared minus 7. Only x squared minus 7 will stay. And the second quantity is 3, 9, and we always subtracting. Okay, let's see what we have. Limit as x goes to negative 4. I have x plus 4, square root plus 3, x squared minus 7. And let me try to maybe work here. This will be x squared minus 16, and I can factor out as a x minus 4, x plus 4. That means this is my current denominator, x minus 4, x plus 4. That's we can see the common factor, but we did have extra job. Okay, that's my 0. After cancelling the 0, not having the 0 in the denominator, I definitely will get a finite number. X square root plus 3, and this is all over x minus 4. Okay? That means I can put negative 4. Negative 4 squared is 16. 16 minus 7 is 9. Okay, and negative 4 minus 4. Negative 4, 3 plus 3 is 6, and negative 8. We can simplify negative 4 dividing by negative 4 is 1, negative 8 divided by negative 4 is 2. That's when we do have 6 over 2, actually it's 3. Yeah, we don't have to multiply, and okay, the limit is 3. That means again, function is not defined at negative 4, function is not defined, but function will be at the level 3. Removable discontinuity. We have just the open dot. Okay, now limit number 7. Please make sure that you're confident with all of the limits solved here. Okay, maybe limit like that. Limit as x goes to 3, and the rational function 1 over x minus 1 over 3, x minus 3. That's when we can see direct substitution will tell me 1/3 minus 1/3, 3 minus 3. Again, 0 over 0. Most likely the answer will be as if like finite number, because we have to find the common factor, cancel out, and especially cancel out the 0 from the denominator. Okay, first of all, what I can do, I have to find a common denominator on the top. That means I will take care of this. The common denominator is x times 3. That means, let me write this. I will multiply by 3, the first, and I will multiply by x, the second fraction. Excellent. Limit x approaches 3. I do have 3 minus x over 3x. Okay, let's see. We do have again 3 minus x over 3x, and dividing by a number, x minus 3, means multiply by the reciprocal. Okay, I almost see the common factor, but let's use a little bit of algebra, and I will factor out negative. Factoring out negative, I end up having x minus 3, exactly the same thing. Okay, that's my 0. The 0 is gone. I can use my direct substitution. Function looks like negative 1 over 3x. Substituting 3, I'm getting negative 1 over 9, negative 1/9. And really quickly, I can indicate at 3, function is at negative 1/9 level. No value, open circle. I don't know how function looks like, but something like that. Open circle, because value doesn't exist. Okay, limit number 8. Maybe something like that. Limit as x goes to 2 from the right hand side, 3 plus x over 2 minus x. Okay, direct substitution is telling me 3 plus 2, 2 minus 2, 5 over 0. Okay, a little bit different. A number over small number means big number. Positive or negative. That's big number. 0 is the small number. Okay, please remember, if you see the multiple choice option, finite number over 0 means big number. Okay? That means that's what we most likely the answer will be positive or negative infinity. And let's investigate. That means what I can do. Let me rewrite one more time. That's x. Okay. And I know that this is 5. And this is 0, but it's not really 0, it's just the indication of the small number, because this is not really 0, because this is not really 2, it's 2.1, or maybe even closer, 2.01. When I subtract 2 minus 2.1, I'm getting small number but negative. Negative, that means this is 0 from the left hand side. 5 over positive over negative, it's negative, and of course infinity, because 1 over small, it's in formal notation, but I can write for you. 1 over small is big. Okay, and this of course indicates 1 over 0 is infinity. You have to investigate if it's positive or negative. Okay, that means you have to check the sign. But please remember, 1 over small is big. Or later we will have this. 1 over big, it's small. That means if you will end up with 1 over infinity, it's always 0. That's really informal. Okay? I can possibly remove that because we're not really writing, but that's what I mean. Okay, limit number 9. Limit number 9 will be this one. Limit as x goes to 3 from the right hand side, 9 minus x squared, and x 3 minus x. Okay, direct substitution always. 9 minus 3 is 6. 6 squared is 36. This is 3, and 3 minus 3 is 0. Okay, 36 over 0. Finite number over small number will give me big number, but you have to check if it's positive or negative big number. And let's investigate what kind of 0 we have. Limit as x goes to 3 from the right hand side, 9 minus x minus 3, I will just substitute, this is x and this is 3 minus x. Okay, this is squared, 9 minus 3 is 6, it's 36, positive. This is 3, and now this is 0. That means 0, let's check from if it's positive or negative, the left or the right hand side. This is 0 of course, but it's theoretically it's not 0 because this is not 3. 3 from the right hand side means 3.1, or maybe closer, 3.1. 3 minus 3.1 is giving me small number 0, but negative again, negative. That means this is that negative, it's telling me that the 0 is negative. Okay, positive 36, positive 3, and negative will give me arithmetically negative, and of course is infinity. Finite number over 0, like a number over small number, is a big number, in this case negative. Okay, and let's solve one more limit, number 10. Maybe the absolute value. Limit as x goes to 4 from the left hand side, 16 minus x squared, 3x minus 12, absolute value. Okay, direct substitution, I am guessing 16 minus 16, 0, 12 minus 12, 0. Okay, that means good sign, because 0 over 0 will tell me that I will have a common factor at 4. Maybe I can find out, cancel out, and get a finite number. Let's see. Limit as x goes to 4 from the left. We have to rewrite without the absolute value and also simplify. That means I see 4 minus x and 4 plus x on the top. I can factor out 3 at the moment. Okay, now the absolute value. We know that if the absolute value, like for example, let me put absolute value of 5, it's simply 5, no problem. Actually, let me use different color. Absolute value of 5 is the same number. That means if the quantity inside is positive, we can ignore absolute value. But if the quantity inside is negative, I can't simply say like this one. I can't ignore absolute value. What I have to do, I have to, with the additional negative, I have to make it positive. Of course, we know the answer right away. The answer is 5, but we can see this is the point. The point is that negative number, if the quantity inside is negative, because negative and negative will give me positive. That means let's investigate. Actually, I have to, okay, let's investigate the absolute value. Then I can, that means this quantity is 4 from the left, which is 3.9, or maybe 3.99. When I subtract 4, I am actually getting negative number. We can see negative number. That means the quantity inside is negative. Let's rewrite. Let's see what we have to do. I will keep this one for now. Okay, and I have 3. And now, let me actually put that 3 outside. I mean, I will just change the order. Okay, that means my quantity x minus 4, it's negative. Okay, we can see it's like negative 5. That's the reason that I have to put extra negative to make it positive. Okay, that means negative and negative will give me positive. That's what I want. Okay, that means now I did use the definition. Now I have to simply use the algebra and basic arithmetic and finish the question. Okay, I do have 3, and then I can possibly distribute this negative x plus 4. And that's mean what I did distribute the negative. Then I will have, I can rewrite one more time. You probably know the answer, but I have 4 minus x plus 4, and then negative x plus 4 is actually 4 minus x if I switch the order. Now I can nicely see the common factor. My 0 is gone. Okay, and the final answer will be 4 plus 4 over 3. 8 over 3, just the direct substitution. And let's finalize. At 4, the limit will be 8 over 3. And function, I don't know, it's the rational function. Maybe will be like that, maybe different. I don't know because I didn't check different things. Okay, that means make sure that you're confident with all of the limits and you will be good in the calculus.